All right, so in example 2, we're going to look at kind of 3 different problems. And what we're going to look at is we're going to compare our and probabilities to our conditional probabilities. So we're going to use the same table that we used in the previous sections. So for example A, what is the probability that the person is married and has a college education or higher? So here we clearly see the word and. But what we want to do is we want to look at what is the question asking us about. Well, it's asking us about a randomly selected person. And since we're being asked about a randomly selected person, that means we're thinking about our total for our entire group. Right, so then to find this probability, right, we have 98 people that were married and had a college education or higher. So we're going to take this 98 divided by our denominator, which is going to be the total number of people, right, which is 665. 98 divided by 665 gives us 0.147 or 14.7%. Again, we actually did this exact same problem back in section 5.2, but this we're kind of focusing on how the question is being phrased. So we're being asked about a randomly selected person, so we're using our entire group. All right, for B, what is the probability that a college-educated person is married? So in this case, our group that we're restricting ourselves to is someone that is college educated. So this group that we're restricting to is our portion that we are given that. So we are given that they have a college degree or higher. Right? And what we are being asked about is the probability that the person is married. All right, so our numerator is actually going to be the same. So we still have 98 people that are married and have a college education or higher. The difference is, instead of looking at our total of 665, we are focusing on the ones that have a college degree or higher. So we're going to divide by a different total this time. We're going to divide by 143. Okay. 98 divided by 143 gives 0.685 or 68.5%. So it was a conditional probability because we restricted our group to those students that were college educated. Right? That is what we were given. And our notation here shows that. The probability that a person is married given that they have a college degree or higher. All right, so in C, one more. What is the probability that a person who is married has a college education? So this question is really asking, again, the probability that a person who is married. So given that the person is married, that the person has a college degree or higher. Again, numerator hasn't changed. It's still the 98. But what has changed is that now we are looking at a person who is married. So our denominator is now going to be 408. So we're going to take 98 divided by our 408, and that's going to give us 0.240 or 24%. So as you're working through these problems, again, what we're looking for, what we're thinking about is, are we looking at our entire group? Do we have an and problem? Or are we focusing on one of our smaller groups? Do we have a conditional probability problem?